We've been talking about exponentials and logarithms. And how they are inverses of each other. So today we want to take a look at solving equations that include exponentials or logarithms. We're going to start off with the exponentials. And we looked at several exponential equations that might have the form of, 2 to the power of 3x minus 7 equals 8 to the power of 5x plus 2, where we had to adjust the base of those exponents to make them the same. 2 can't be simplified or changed, but 8 can be expressed as 2 to the power of 3. So that to the power of 5x plus 2 becomes 2 to the power of 15x plus 6. Because these had the same base, the base of 2 in our exponent, we could eliminate both of them with a log base 2. So they disappeared, and we had an equation like 3x minus 7 equals 15x plus 6. And we could solve from there. This is just in a linear equation, so I'm going to buzz through solving it rather quickly here. I can subtract 3x. So we got negative 7 equals 12x plus 6. We would subtract the 6. So negative 13 equals 12x. And finally, divide by 12. To get negative 1 1/12, or negative 1.083 repeating, equals x. The next step, and we looked at this briefly on Wednesday, is what to do when we don't have the same base of an exponent on each side. We might have something like 6 to the power of x equals 400. Well, to solve this, it's the same thing. It's just we're going to actually have to calculate the... Okay. So it's the same thing. We'll actually have to calculate the logarithm rather than just canceling things out. So what base of a logarithm do we have to use here? Well, the base of our exponent is base 6. It's 6 to the power of x. So the base of our logarithm has to be base 6 as well. The base of the log has to match the base of the exponent. So this is a log base 6. So on the left side, the logs do cancel out. Log base 6 and a base of 6 in our exponent cancel out. That leaves us with just x. On the right side, however, we have to calculate the log base 6 of 400. We don't have a log base 6 button on our calculator, so how did we calculate that? Log 400 divided by what? Of 6, right? Log of the object divided by log of the base. Does it matter whether we use log or ln? No, they both come out to be the same. Log of 400, or ln of 400 divided by ln of 6 is 3.34. Log of 400 divided by log of 6 is 3.344. So either way, we get the same value. These can get more complicated. We might have 15 to the power of 2x minus 1 plus 17 equals 912. First, just like with linear equations, we have to do some prep work to get it where we need to. Also, like our radical equations, where I had to isolate the radical, here with an exponential equation, we have to isolate the exponential. The exponential, remember, is the part with the power where the variable is in the power of the exponent. So that's the exponential. So I have to get rid of the plus 17. How do I get rid of that plus 17? I subtract 17. Good. So I now have 15 to the power of 2x minus 1 equals 895. So I have isolated the exponential. Now that it's isolated, I can go ahead and undo or cancel out the exponential. How am I going to cancel out the exponential here? It's going to be a log. Log of what base? 15. Good. So the log base 15 and the base of 15 in my exponential cancel out, leaving me with the 2x minus 1. On the other side, I need to find the log base 15 of 892. How do I do that? Or not 892. That should be 895, shouldn't it? Log base 15 of 895, how do I do that? Perfect. Log of 895 divided by log of 15 gives us 2.510. Rounded to 3 decimal places. We're not done yet, though. We still have an equation to solve. This is 2x minus 1 equals 2.510. What do I have to do to solve that? Add 1, so 2x equals 3.510, and then divide by 2. X equals 1.755. Time for you guys to try one or two. So the first one I'm going to have you try. 7 to the power of 3x plus 4 minus 15 equals 34. The second one I'm going to have you do, 3 to the power of the square root of 2x plus 1 plus 5 equals 83. I'm going to have you try both of those. We'll go over them in just a couple minutes. Let's take a look, see how you're doing. So for both of these, we have to isolate the exponential before we can do anything with it. So for the first one, we'll start by adding 15. So we get 7 to the power of 3x plus 4 equals 49. Then what do we do? We have to do a log base 7. That cancels out the base of 7 in our exponent, so we get 3x plus 4 equals 49 log base 7 should be 2. If you do log of 49 divided by log of 7, you get 2. Now we solve that equation from there. We subtract 4. (3x) equals negative 2. Now we divide by 3. X is a negative 2/3. How many of you had negative 2/3 for that one? Oh, sure. Any questions on how we did that? Exactly. You could have done that. If you saw that 49 was 7 squared, and then you could just cancel out the 7s and have the 3x plus 4 equals 2. Yes. The second one here. We still, again, we have to isolate the exponential. We're going to subtract 5. So this is 3 to the power of the square root of 2x plus 1 equals 78. What's next? Log base 3. So again, that cancels out the base of 3 in the exponential. We have a square root of 2x plus 1 here. Log base 3 of 78 is log 78 divided by log of 3. 3.966. Now I'm going to keep that in my calculator so that I don't have round off errors building up too much. What's my next step going to be here? I have to square it. So squaring and square root cancel out, leaves us with 2x plus 1. If I square my 3.6 whatever, I get 15.726. Now what do I do? Subtract 1. 2x equals 14.726. And then we divide by 2. Good. X equals 7.363. Approximately. If you're within a couple thousandths of that, you're okay. Any questions? I'm going to have you try one more before we move on. Try that one. What's happening here? There we go. We subtract 18. We have 5 to the 7x minus 11 equals negative 7. What type of log should we do here? A log base 5. On the left side, the log base 5 and the base of 5 and the exponent cancel out. That's 7x minus 11. However, on the other side, log of negative 7, I'm not even going to try to do the log divided by the log of 5 because we cannot take the log of a negative number. We can't take the log of anything small. Actually, we can't even take the log of 0. Log of 0 doesn't work. Anything that is less than or equal to 0, we cannot take a log of. So this has no solution. There are no real numbers that define the log of a negative number, no matter what the base is. We might have something like this. Seven times 9 to the power of 3 times the square root of 2x minus 1 plus 4, plus 11 equals 95. Now, this one's a mouthful, so we're going to work through it together. Remember, the first step is to isolate the exponential. The exponential here is just the 9 to the power of that ugly mess. How do we get that by itself? Perfect. We subtract the 11, so we're left with 7 times 9 to the power of 3 times the square root of 2x minus 1 plus 4 equals 84. And then we need to, you'd said it, Ezra? Divide by 7. Perfect. So 9 to the power of 3 times 2x minus 1 plus 4 equals 12. Now the exponential is by itself. We've isolated it. What do? Log base 9. You got it. So again, on the left side, the log base 9 and the base of 9 in the exponent cancel out. We've got 3 times the square root of 2x minus 1, all plus 4. On the right side, got to do log of 12 divided by log of 9. 1.131. Now what? Yeah, now this is a radical equation. We have to isolate the radical. We subtract 4. 3 times the square root of 2x minus 1 equals negative 2.869. And then we still have to divide by 3. Square root of 2x minus 1 equals a negative 0.956. Basically, that'll round to. It's 0.95633. So what I'm going to do this in my calculator just to kind of keep it current. I subtracted 4. Then I divided that by 3. That rounds to 0.95635 and so on. I'm going to leave that in my calculator because what's my next step that I have to do here? I have to get rid of that square root by squaring it. You are correct. So the squared and the square root cancel out. 2x minus 1 equals, if I square, that answer, I get 0.915 basically. Then what? Plus 1. So 2x equals 1.915, and then divide by 2, perfect. X equals 0.958, basically. So that comes out to be. What do you think? Not so bad? Now, of course, this one is actually a little bit easier to do, even though it looks more complicated. That e in there can be intimidating. But remember, the exponential here is just e to the power of 3x. So to solve this, we have to isolate that. We add the 5. 2 times e to the power of 3x equals 22. And then divide by 2. E to the power of 3x equals 11. Now what do we have to do? It's log base e. Oops, go ahead, Ezra.
No, I don't know.
Well, it's log base e, otherwise known as natural log, or ln. Yep. So the ln and the e to the power of cancel out. We got 3x. ln of 11, we can just put in ln of 11 in our calculator. 2.398. And then we divide by 3. X equals 0.799. What do you think? Good. We've looked at solving logarithmic equations. We had all these rules for combining logs that are necessary because we can't have log of more than one thing on each side. We do have to have, one term on each side of an equation to make it work. But we can have a logarithmic equation like, we had basic ones of log base x of 125 equals 3. And the way we've solved these so far is we turn them into their equivalent exponential equation. What is the exponential equation that's the equivalent of this? Yeah, x to the third power is 125. The base of the log is the base of the exponential. And of course, from there you could figure out that x has to equal 5. Or we had log base 7 of x equals 4. This one's actually relatively simple to figure out because what is the corresponding exponential form of that? The base of the log. Just go ahead. Perfect. 7 to the 4th equals x. The base of the log is the base of the exponential. So that's the 7. So the 4th power equals x. And of course, x is 2,401. The ones that were more, and this is actually the ones that are going to be taking place in most of our exponential equations we solve today. We might have log base 3 of 729 equals x. And this is where we had to just calculate it out. That's saying 3 to the power of x equals 729. We had to figure out what x is. Well, this is easier to solve if we left it in exponential form. We can do the log of 729 divided by the log of 3, getting us 6. X is 6. Like I said, we're going to focus on this form here today. Rather than turning that into an exponential, we might have the log of 2x minus 5 equals 700. Now first, I don't have a base written here for my log, so what base do I assume? 10. Just like with exponentials, I have to isolate the log. Here the log is isolated. So what do I have to do now? Before, we used the log to get rid of the base of an exponent. Here, we use the base of an exponent to get rid of a log. That's log base 10, so we put it into an exponent with a base of 10. So that exponent with a base of 10 and the log base 10 cancel out, leaving us with 2x minus 5. 10 to the power of 700. Well, I'm going to write it as 10 to the power of 700 because that's huge. I meant to write 10 to the power of 7. I'm going to actually, let's do that. I'm going to take my zeros off so that we can actually work with it. 10 to the power of 7 is still 10 million. Now, I solve for x by adding 5. So 2x equals 10 million and 5. Now we divide by 2. X equals 5 million and 2.5. So while most exponentials equal a large number so that when we do the log we get a reasonable size, most logarithmic equations equal a very small number so that we get a reasonable size when we solve the equation. If I had a log base 7 of 3x minus 4 equals 0.1. What do I have to do to solve this? Yeah, 7 to the power of each side. We do an exponent with a base of 7. So on the left side, the base of 7 in the exponent and the log base 7 cancel out. I get 3x minus 4. On the right side, 7 to the power of 0.1 is 1.215. And then what do we have to do? Add 4. 3x equals 5.215, and then?
By 3, 1.738.
1.738 works for me. Any questions? Well, let's have a little fun with this. (17 plus 3 times log base 2 of 5x plus 2 equals 23. Better be careful. Let's do 25. Otherwise, it's going to get way too easy. Remember, we have to isolate the log. That part is the log. To isolate it here, we have to do what? Subtract 17. Good. So 3 times the log base 2 of 5x plus 2 equals 8. And then? Divide by 3. Log base 2 of 5x plus 2 equals 2 2/3. And then?
The base 2.
Yeah, exponent with a base of 2, 2 to the power of. Cancels out the log. So we've just got 5x plus 2 on the left side. 2 to the power of 2 2/3. 6.350. And then? Subtract 2. 5x equals 4.350. And then? Divide by the 5. X equals 0.870. Are we having fun yet?
Not yet, let's do another one.
How about you guys try one in a couple in your notes? So 9 minus log of 2x minus 5 equals 22. And our second one, 5 plus 2 times the log base 5 of 3x plus 1 equals, let's do 7. I'll give you a couple minutes to work on them. So our first step here for the first one, we have to isolate the log. What are we going to do? Subtract 9. Even though there's subtraction here, the 9 is still added, so we're subtracting 9. So I've got negative 5 times the log of 2x minus 5 equals 13. Now what?
Divide by negative 5.
We divide by negative 5. Log of 2x minus 5 equals negative 2.6. And at this point, we know that there is no solution, right? We can't have a log equal negative. No. An exponential cannot equal a negative. A logarithm can. Because to solve this, what are we going to do? It's going to be 10 to the power of, because that's log with nothing written there, so we assume it's log base 10. That cancels to give us 2x minus 5 equals 10 to the power of negative 2.6 can be done. It's 0.0025. Next, we will add the 5. 2x equals 5.0025. And then divide by 2. X equals 2.501 basically, or 0.2 depending on how you want to do it. It's actually 1. Any questions there? How many of you had that one right? Do you see what we did wrong there? How many of you stopped when you got the negative? Okay. Hopefully number 2 went better for us. Number 2, we're going to subtract 5. So 2 times log base 5 of 3x plus 1 equals 2. And then divide by 2. So log base 5 of 3x plus 1 equals 1. And then to the base 5. So 5 to the power of, 5 to the power of. So the log base 5 and the base of 5 and the exponent cancel out. 3x plus 1 equals 5 to the power of 1 is just 5. And then subtract 1. 3x equals 4. And finally, divide by 3. X is 4/3 or 1 1/3. Any questions? Well, how about if we have 3 times log base 4 of x plus log base 4 of x minus 1 equals 0. This one looks like a nightmare. But remember our rules of logs. We can combine logarithms. I'm going to start with this piece here. The number multiplying a log, remember, is a power on the object of the log. 3 times log base 4 of x is equivalent to log base 4 of x cubed. Does that look familiar to everybody from last week? Okay. So next, we have logs that are being added together. Remember, when we're adding 2 logs, that means the objects, as long as they're the same base, that means the objects of those 2 logs can be multiplied. So I can combine those two to get log base 4 of x to the third times x minus 1 equals 0. So now this is log base 4 of x to the fourth minus x to the third equals 0. Now what do we do?
Base 4.
4 to the power of, yes, an exponent with a base of 4. So the 4 to the power of and the log base 4 cancel out, leaving us with x to the fourth minus x to the third. What's 4 to the power of 0?
No.
1. Very good. Anything to the power of 0 is 1. Now we have to solve this. Oops. It would be x to the fourth minus x to the third minus 1 equals 0. And unfortunately, that is not an equation that we are capable of solving at this time. So we would be stopping right there for now. Any questions? Okay. Next step, I want to get the natural logs in there. So what would we do here? Well, the log is by itself. What base does our exponent need to be? E, very good, base E. So on the left side, the E and the ln cancel out. We have 2x plus 5 equals. Now on your calculator, to do e to the power of 4, remember it's that second function above the ln. You do second e to the x, and then 4. 54.598. Then what do we do? Subtract 5. 2x equals 49.598. And then? Divide by 2. Good. X equals 24.799. Any questions there?
On my ln key, there's an e to the x, and then there's another e. What's the difference?
The other e is actually a scientific notation key. I'm going to have you try this one in your notes. I'll give you a minute or two. What do we do first? Subtract 7. Good. So that gives us that negative 2 times e to the 3x minus 5 equals negative 3. And then we divide by negative 2. E to the 3x minus 5 equals 1.5. And then what's that? Natural log. Very good. Three x minus 5 equals ln of 1.5, 0.405. And then add 5. Come on now. 3x equals 5.405. And finally, divide by 3. X equals 1.802 approximately. Try this one. See what you can do with that one. Your instinct is to want to jump in here and try to isolate the exponent or the logarithm. Can't do that on this one. This one you can actually combine the logarithms. Remember, 2 ln x is ln of x squared. And then ln x squared plus ln of negative 4 is ln of x squared minus 4 equals 7. Then we do the e to the power of. We got x squared minus 4 equals e to the power of 7 might get kind of large. 1096.633. And now we just solve for x. So we're going to add the 4. X squared equals 2000.633, or sorry, not 2000, 1100.633. And we square root. To get x equals 33.176. What do you think? Not too bad? Well, let's look at some applications of these equations. We looked a little bit last class at compound interest. So our technical compound interest formula looks like this. The future value equals the present value times 1 plus, now we just put rate in here before because we're doing compounded annually. It's technically rate divided by n, where n is the number of periods in a year, to the power of, before we just put t for the number of years, well, it's n times t, that's the number of periods. So if it's compounded monthly, n is 12. If it's compounded quarterly, n is 4, because that's 4 times per year, and so on. How long would it take for $5,000 to grow to $8,000 at 7% compounded monthly? So we know we want the future value to be 8,000. We're going to try to grow to 8,000. We're starting at 5,000 times 1 plus, our rate is 7%, that's 0.07. N is the number of times per year, compounded monthly, so that's going to be 12. Close that, that's the power then of 12 times t, where t is our number of years. So we're solving for t. This is an exponential equation. The variable is in the power of an exponent. We solve by isolating the exponent. So we're going to divide by 5,000. This doesn't look like it is isolated right now, but it is. The exponent in here is 1 plus 0.007 divided by 12. That is the base of our exponent. That's going to be the base of our log. So this is the log base 1 plus, not 0.007, 0.07, not 00. Got an extra 0 in there. 1 plus 0.07 divided by 12 is the base of our log. So on this side, it's going to cancel out. On the right side, we just have 12t. On the left side, we've got log of 1.6 divided by the log of 1 plus 0.07 divided by 12. 80.807. And we finish that off by dividing by 12. $6.734. And of course, t is years, so that's 6.734 years it would take to grow from 5,000 to 8,000 at that rate. Any questions on that? So in this formula, this whole piece was the base of that exponent because it's in parentheses and the exponent is outside the parentheses. In contrast to that, we have examples like this. The charge on a capacitor at a given point in time, if we have a applied voltage of capital V, the actual voltage on the capacitor, VC is the voltage on the capacitor, is equal to that applied voltage times 1 minus e to the power of negative t divided by RC. R is the resistance of the circuit, C is the capacitance of the circuit. So let's say that we have an applied voltage of 120 volts. A resistance of 2,500 ohms. A capacitance of 0.003 farads. At what time will the charge Vc equal 80 volts? So we're putting 80 in for Vc. Equals, our applied voltage is 120, times 1 minus e to the power of negative t. T is what we're solving for. I'm going to put R times C in parentheses here. That's going to be 2,500 times 0.003. So as always, our first thing to do is isolate the exponential. So we're going to go ahead and divide by 120 here. So we have 2/3 equals 1 minus e to the negative t over, I'm going to go ahead and multiply that out. 2,500 divided by 0.003 is 7.5. You'll notice, however, that the power here, the negative t over that, it's on the e, but it's inside the parentheses, not outside the parentheses. That means it is just on the e, so only the e is part of the exponential. So before we do a log to solve this, I still have to get rid of the 1, so I'm going to subtract that 1. So 2/3 minus 1 is a negative 1/3 equals, this is negative e to the power of negative t over 7.5. Now I have to divide by negative 1. 1/3 equals e to the power of negative t over 7.5. What do I do next? ln is correct. Those are gone. So on the right side, we've got negative t over 7.5. On the left side, ln of 1/3, negative 1.099. Now what? Not 7. Well, I could do 7.5, but then I'd have to do one more step. I can combine two steps by doing times negative 7.5. That gets rid of the 7.5 and the negative. So negative that times negative 7.5. 8.240. That is, time is in seconds in that formula, so that's 8.24 seconds before that charges to 80 volts. What do you think?
I think I'm on my last sheet of paper.
Wow, you did time that just about perfect. Well, homework 16A in my math lab deals with the content from today. That is our last homework assignment for the semester. So that needs to be done by the end of the day Wednesday. Tomorrow, Tuesday's class is review. I'm not going to plan anything for tomorrow. So something I'd like you to do tonight, if you can, is look through that review sheet. Bring a copy of that in with you tomorrow if you get a chance to print it off. And tomorrow we're going to answer questions off that review sheet for you. If you guys don't have questions to ask, that's fine. I'll just randomly pick things to go over, problems to do off that review sheet. But it'd probably be more useful to you if you actually have questions that you're starting, because I don't want to go over stuff that you're all pretty confident in. Do you guys have any questions before we call it a day? Okay, well, oops, go ahead. Yep, you can just do class from home tomorrow. The test will be on Wednesday. You can start, I will send out the test so you can start as early in the morning as you want to. I believe the testing center opens at 8 o'clock, so anytime after 8 o'clock on Wednesday, you'll have 3 hours to complete it. It would make more sense for you, or the most sense for you, if you are going to start early, to maybe not start any earlier than 10 o'clock or so. That way you at least have some of the class time so that you can ask me questions if anything comes up on it. Okay, we'll see you all tomorrow.